Welcome back to All This Math. This is Professor Parker. If you're here, go ahead and hit the like button. Go ahead, just hit the like button. Do us all a favor. All right. If you're not subscribed already, go ahead and subscribe. Hit the subscribe button. All right. Also, when this video is done, I want you to share it with at least one other person. And if you have any questions, put your questions in the comment section. Or if you just have a comment about the video, all right, put that in the comment section. I do want to give a shout out to Prairie View A&M University down in Houston, Texas. Two people come to mind, actually three people. Three people come to mind when I think of Prairie View A&M. One is the late Dr. Jacob Carruthers. Dr. Jacob Carruthers was one of the founding members of ASCAC, the Association for the Study of Classical African Civilization. A serious scholar, writer, wrote the book Intellectual Warfare, wrote The Irritated Genie, which is a book about the Haitian Revolution that we should all know about, right? Wrote multiple other books and essays as well, and was a teacher. He taught at Prairie View A&M University for a brief period of time. All right. Also, I think of Sundiata Acoli. Sundiata Acoli was a member of the Black Liberation Army, along with Assata Shakur. Shout out to Assata Shakur. She's right there. All right. He was a mathematics major at Prairie View A&M University. And I also think of Percy Sutton. Percy Sutton was the attorney for Malcolm X. He was one of Malcolm X's attorneys back in the 1960s, and he's also an alum of Prairie View A&M University down in Houston, Texas. So those are just some people that come to mind when I think of Prairie View A&M University. And of course, I got because I got a couple Prairie View A&M University sweatshirts. I didn't go to Prairie View A&M, but I just promote black colleges. You know what I'm saying? And I thought this sweatshirt was kind of fly, so I grabbed it a few years back. So all right, so I just wanted to say that. All right, now what else are we doing? We're about to solve an equation. All right. So look at what we have here. We're going to solve for x. And let's first read the equation. Let's just read it. It says 5 times the quantity of, we don't say parentheses, we say the quantity of 2x minus 1. Whatever's in the parentheses is a quantity, right? It's an amount, right? So 5 times the quantity of 2x minus 1 minus 2 is equal to 13. So when you first look at an equation on the board or on paper or online somewhere, think about it in terms of sports, like how a basketball player has court vision, right? How a football player can, like, size up the field and scope the field out and know where the holes are going to develop, know where everybody's going to run, know where everybody's supposed to be at. Even in baseball, like, or soccer, right? Sometimes you got to just, when you're looking at a math problem, just kind of just sit back for a minute and just size it up, right? Because when I'm looking at this, I know my goal is to solve for x, so I want to isolate this x by itself. So my first thought is like, well, what do I need to get rid of so that this x can be by itself, right? It's a lot of stuff over here on the left side of the equation, right? I know I need to get rid of this -2. That's got to go. This -1 got to go. This 2 right here got to go. This 5 got to go. So all them things got to go. So that's 1, 2, 3, 4. 4 things got to go, right? 4 things got to go. We got to get 4 things out of here. So this x can be isolated all by itself, because that's our goal. Our goal is to isolate x, because then we'll know what x is equal to in terms of a number that will make this a true statement, because math is all about finding the truth. So anybody out here that likes to find the truth and don't like being lied to, right? You should like math, because math is all about all these different ways of finding out the truth. And it's all these different formulas and, theories and everything that we use basically to find out the truth. That's what we try and find out. We trying to answer questions and find out the truth, right? When you strip it all down to its basic form, what I mean? That's all we trying to do. We trying to find out the truth, right? So we want to solve for x, right? We want to isolate x by itself. Now there's a process to doing that. So you got to first decide, okay, what do I want to get rid of first? So what I'm gonna get rid of first is this -2, right? It's a -2, right? Then I'm gonna get rid of this 5, right? By either doing division, which is the opposite operation, or I might distribute the 5 to everything inside the parentheses. Make sure we understand what the distributive property is, what that means, and what that says. All right. But look, first, let's get rid of this -2. Now, what's the opposite of -2? The opposite of -2 is +2. So first thing is, and we do this constantly, this is going to help develop our critical thinking ability. We get into the habit when we're solving equations. Identify what you need to get rid of, identify what that thing is doing, and then identify what the opposite operation is, and then do the opposite operation. So those 3 questions, those 3 things you got to do, like, consistently throughout the process of solving an equation. Identify what you got to think about. What do I need to get rid of? That's helping you develop your critical thinking ability. So when you solving equations, you're developing your critical thinking ability. So all the people that be talking about, why I got to learn this, how's this going to help me in life, when am I ever going to use this? Well, I hope you have critical thinking ability. And there are a lot of people that don't use critical thinking ability, and you see how they end up. You see how they end up all along, all the time. we try to, blame it on other things, but at the bottom of it, at the base of it, a lot of times it's just people don't have critical thinking ability. And math class is a place where you can practice developing critical thinking ability on a daily basis, every single day. But a lot of, math teachers don't understand that. When I first started teaching 20 years ago, I didn't understand that. So of course I wasn't telling my students that. I wasn't giving them that game because I didn't know. But now I know. So I say this all the time on my channel, on this YouTube channel and on my videos. I say it all the time. Look, this is how you develop critical thinking ability. This is one of the best ways to do it. Practicing math. I'm trying to tell you. It's the best kept secret. All right. So now, like I said, we already decided we want to get rid of this -2. So we need to do the opposite operation, which is to add 2. All right. And also, we stay balanced, right? We keep it balanced like Mayat from ancient Kemet, right? If we do +2 on the left side, we got to also do +2 on the right side. So we're going to do +2 over here, right? -2 plus 2, you got to know that that adds up to 0. So these cancel out. All right. Then over here, we got 15 because 13 plus 2 is 15. Make sure you know your addition facts. And please don't take out a calculator to do 13 plus 2. If you need a calculator for that, you're not living right. You know what I'm saying? If you're at this level where you like solving equations like this and you need the calculator to do 13 plus 2, just practice. Just practice your addition facts. Do yourself a favor. All right, bring this down. We're going to have 5 times the quantity of 2x minus 1 is equal to that. Now, what I'm going to get rid of next? I'm going to get rid of this 5. I'm going to get rid of this 5. Now, I could divide by 5 to get rid of it because 5 is being multiplied by this quantity. And what is the opposite of multiplication? Division, right? Or I could distribute the 5. Either way, it works, right? Either way, you know what I'm saying? It's a way for me to get rid of the 5, right? Either the 5 can be absorbed or like assimilated into this group or integrated into this group, right? This quantity, right? Or we could just divide the 5 on both sides. I feel like dividing. Why am I dividing? Because I feel like it, right? I got options. It's good to have options. When we solving equations, we got options. All right. So let's divide by 5. Let's divide by 5 on the left side. Now, whatever I do on the left side, I do on the right side. Just like I added 2, I added 2, I added 2, I added 2. Divide by 5, divide by 5. Divide by 5 on the left, divide by 5 on the right. Now, what's 5 divided by 5? That's 1, right? So then we left with 1 times 2x minus 1. Now, again, a lot of things we write in algebra are just slang. Instead of writing 1 times 2x minus 1, I could just write 2x minus 1. You don't got to say 1 times 2x minus 1 because the product would be 2x minus 1 anyway. So that 1 is unnecessary. All right, so we're just going to do that. They're going to become 1s. Then you're going to have 2x minus 1. And what's 15 divided by 3? Make sure you know your division facts. You need to know that 15 divided by 5 is 3. You need to know that from memory. All right, no calculator. You don't need a calculator for that. And if you're a person right now that needs a calculator for that, decide and commit to learning your division facts because they are yours. So learn them. 15 divided by 5. Don't make the careless error and do the subtraction instead. Don't say it's 10. It's not. All right. Be careful. Check your work as you go along, as you go through step by step. 15 divided by 5 is 3. Then you go back and say, make sure, okay, 15 divided by, where'd that 3 come from? Yeah, 15 divided by 5 is 3. All right. Constantly check your work. Constantly check your work. All right. So now we got 2x minus 1 equals 3. I got to get rid of 2 more things because I'm trying to get x by itself. This -1 and this 2. This -1 and this 2. Now the question, what do I get rid of next? It don't matter. We could get rid of the 2 right now or the -1 right now. And I will tell you, I've been doing this a long time. I've been doing problems like this a long time. I did thousands and thousands of them. If you get rid of the coefficient, that's math vocabulary. The coefficient is the number attached to the variable. That tells you how many of the variable you have. We got 2 x's. That's how many x's we got. We got 2 of them. 2x means we got 2 x's, right? If you get rid of the coefficient first, oftentimes, not always, but oftentimes, it is going to make your problem look messy, right? And we could still do it, but if you could avoid a messy situation, then why not avoid it, right? So I'm just telling you, that's just a word from the wise. I'm not telling you what I think. I'm telling you what I know, right? Usually when you get rid of the coefficient, that's going to make the problem look messy, right? So let's keep it cute, as people say. You know what I'm saying? Like, let's keep it cute, right? So we want to get rid of this -1 first, right? So we get rid of the -1. What's the opposite of subtracting 1? The opposite of subtracting 1 is adding 1. All right, so you're going to add 1, but then again, like our ancestors, ancient Kemet, back in the day, 6,000, 8,000 years ago, if we add 1 on the left side, we got to add 1 on the right side. So -1 plus 1 is 0. -1 plus 1 is 0. Make sure you know that. That's the whole purpose of adding 1, to get rid of that. 2x, bring that down. What's 3 plus 1? 4. Now we got 1 step left. Get rid of this 2. What's the 2 doing with the x? What they doing together? They're multiplying with each other. What's the opposite of multiplication? Division. So that's what we're going to do to get rid of the 2. You're going to divide by 2 on the left side. Keep it balanced. Keep it balanced. Divide by 2 on the right side. What's 2 divided by 2? 2 divided by 2 is 1. Again, in math, we use a lot of slang, right? A lot of the notation we use in math is basically, it's just like slang. Because instead of saying 1x, because 2 divided by 2 is 1, which leaves us with 1x. Instead of saying 1x, we could just say x. We don't need to say 1x. All right. So now let's do this. Let's slide up here. We got more space up here. So the 2 divided by 2 is 1. So we got 1x, which is just x. 1x and x are the same thing. Then you bring your equal sign next to it. What's 4 divided by 2? 4 divided by 2. A fraction is just a representation of a division problem. For real, for real. What's 4 divided by 2? That's 2. So we got x equals 2. Now we think that's the answer, but you should always go back and check your work. Always check your work. Don't wait for somebody to tell you that it's right. All right, so we're going to do 5. Because I told you earlier, I told you that the purpose of math is to find the truth. So I'm rewriting the original equation, except I replace the x with this 2, right? And it's not 22. It's not 22, right? It's not 22. You know why? Because this says 2 times x. That's what 2x means. 2x means 2 times x. So if you're replacing the x with a 2, why would ask yourself, why would it be 22? Nah, you follow what it already was. It already was 2 times whatever this is. Now you know what that is. It's 2. So you're doing 2 times 2. 2 times 2. It's not going to be 22. All right. You got to take into consideration what the operation is. What the operation is. This should not become 22. I repeat, this should not become 22. So now in here, we're just going to follow the order of operations and see if all of this on the left side actually is equal to 13. All right. So in the parentheses, we got 2 times 2, which is 4. And then 4 minus 1 is 3. Then we got 5 times 3, which is 15. And then we still got the minus 2 out there. So the question is this the truth? Is 15 minus 2 equal to 13? Yeah, it is. And 13 is equal to 13. So in algebra, true statements come from correct answers. Correct answers, so you draw a box around it because it's correct. If we got a true statement like 13 equals 13, because 13 is 13, right? I think that's called the reflexive property. Or the symmetric, no, it's reflexive. I think it is reflexive. I think that's the reflexive property. When something is equal to itself, I think it is. I got to look that up. But it's one of those properties, right? It's either reflexive or symmetric. I think it's reflexive. But like I said, I'm going to look it up. If you get a true statement, then that means you had a correct answer. If you get a false statement, then that means you either had an incorrect answer or you did something wrong when you was checking your work. Because that can happen too. Sometimes you could have the right answer, but when you was checking your work, you was tripping. All right? Because that can happen too, because we humans, we make mistakes. But that's why you got to check your work. You got to go back and check your work because you might have made a mistake. All right. So now that's how you solve for X when you see a question like this. But again, like I said, size it up. When you first look at it, like size it up and think, okay, see what I got to get rid of. I got to get rid of this right here, this right here, this right here, and this right here. Then you just got to decide what order do you go in. That's all you got to do. Right. These problems are not that deep. But look, I just showed you how to do it, but you got to practice. You got to put the practice in. It's not simple as just come into the YouTube channel, just watch me do a problem. Like, nah, I make it look easy. But I make it look easy because I done so many of these problems. I done taught so many of these problems. I done taught so many people how to do this. When I was in school, when I was in middle school and high school, I was doing these problems, banging them out. You know what I'm saying? Right? But, so it look easy now, right? Because I was shooting in the gym, right? You know what I mean? It's like, yeah, I was shooting in the gym like back in the day. For years, I've been doing this. That's why I make it look easy, right? You could be this good too. You just gotta put the work in. That's all it is. It ain't no secret. Just put the work in. Get somebody to show you how to do it. I just did that. I showed you the steps. Now you gotta practice. All right. So that being said, this concludes our video. Make sure you are subscribed to the channel. If you ain't hit the like button yet, just go ahead hit the like button. Don't be a hater. Just hit the like button. You know what I'm saying? Also, share this video with at least one other person. Share this video with at least one other person. And drop a comment down below if you got a comment or if you got a question about something I did, something's unclear. That's cool. That happens, right? Drop your question down there. I might make another video just for you in response to your question. You know what I mean? And again, last but not least, another shout out to Prairie View A&M University down in Houston, Texas. Peace.